Hi, everyone. In the following, I'll be presenting the highlights from our recent paper named Constraining Deep Mantle Anisotropy with Shear Wave Splitting Measurements, Challenges and New Measurement Strategies. In this paper, I and my co-authors Maureen Long, Quendai Lang, and Tarja Nissen-Meyer investigate commonly applied shear wave splitting techniques and their underlying ray theoretical assumptions. We also suggest improved and new shear wave splitting strategies. Let's first talk about why the lowermost mantle is interesting. Processes at the base of the mantle play an important role in the thermal evolution of Earth. Heat flow across the core mantle boundary indirectly influences convection in the mantle, for example, by leading to the generation of upwellings that may eventually become plumes. This means that by influencing how the Earth's mantle convects, processes at the core mantle boundary directly or indirectly influence the tectonic features that we can see at the surface. Thus, if we can constrain how material flows at the core mantle boundary, we can also understand surface processes much better. In this work, we are looking at seismic anisotropy because observations of seismic anisotropy can help resolve deep mantle deformation and flow. To study lowermost mantle anisotropy, we test how reliable different ray theoretical assumptions are that are underlying commonly used shear wave splitting techniques. For ray theory, it is assumed that seismic waves are only sensitive to a linear structure along the ray path, which is strictly speaking not correct. Finite frequency seismic waves are sensitive to a whole volume around the ray theoretical ray path, which we can account for by conducting global wave field simulations using XSM 3D. This means we can computationally simulate realistic earthquakes at periods necessary for shear wave splitting measurements and calculate synthetic seismograms for arbitrary anisotropic geometries, for example, including deep mantle anisotropy. We can then apply commonly used shear wave splitting techniques to the synthetic seismograms and check how well we can resolve the seismic anisotropy that we have used in our input models. The takeaways of this paper are rather technical and mainly aimed at the shear wave splitting community. For example, we have demonstrated that the traditional SSCS differential splitting technique does not consider the influence of the core mantle boundary reflection of SCS. We have improved the technique now considering this reflection, and we have shown that this improved technique can accurately retrieve lowermost mantle associated splitting parameters. Additionally, we have shown that the splitting intensity is only commutative for lower absolute values than 1, which plays a role for the frequently applied SKS-SKKS differential splitting technique. We've suggested only using this technique if both phases have lower absolute splitting intensity values than 1. Further, we have invented a new technique that can be used to detect lowermost mantle anisotropy, which relies on SCS waveform comparisons. And here I'm showing an example for where we apply this new technique to a data set that samples the lowermost mantle beneath Eastern Asia. The background colors show velocity perturbations with respect to Prem from the gypsum tomography model. Yellow stars show the events and the red triangles show the stations. The ray paths are plotted in gray, and the ray path length of SCS through the lowermost 150 kilometers of the mantle is plotted in white if we cannot detect evidence for lowermost mantle anisotropy, and in black if we can. And panel A shows that the lowermost mantle beneath East Asia is largely isotropic or weakly anisotropic. The red waveforms here in panel B are an example for waveforms that indicate the presence of lowermost mantle anisotropy, and the blue waveforms are an example for waveforms that indicate the absence of lowermost mantle anisotropy. And if you'd like to know more about this, please have a look at our paper, and thank you all for listening.